In this video, we're going to be getting some more practice differentiating some inverse trig functions. And I went ahead and put all the formulas that we'll have to refer to up here. So these are the derivatives for each of the 6 inverse trig functions. First, we'd like to differentiate the secant inverse of ln of x. And if you look at the formulas here, you'll see that we have a derivative of arcsecant. It's the same thing as secant inverse. And instead of secant inverse of x, here we're dealing with secant inverse of ln of x. So we're going to have the derivative of secant inverse of u, wherein u is ln of x, times du dx. So the derivative of ln of x with respect to x. So this is going to be 1 over the absolute value of ln of x times the square root of ln of x, quantity squared, minus 1, times the derivative of ln of x with respect to x, which is just 1 over x. So you combine these factors and you get 1 over x times the absolute value of ln of x times the square root of ln of x, quantity squared, minus 1. So all we did here was we plugged into this formula, but instead of x we had ln of x. Because u was ln of x, we had to differentiate u with respect to x. So we were not only dealing with a function of x, we were dealing with a function of u of x. So we had to apply the chain rule and differentiate u with respect to x, because remember, this expression here is the derivative of secant inverse of ln of x with respect to ln of x, not with respect to x. To make it with respect to x, we'd have to multiply by the derivative of ln of x. In this next example, we'd like to find the derivative of arcsine of tangent of x. And so we're dealing with the derivative of arcsine of u, wherein u equals tangent of x. And this equation tells us that it's going to be 1 over the square root of 1 minus u squared times du dx, of course. So 1 over the square root of 1 minus u squared, so 1 minus tangent squared of x, times the derivative with respect to x of tangent of x, which is secant squared x. So this is just secant squared x over the square root of 1 minus tangent squared of x. Now we'd like to find the derivative of sine inverse of e of x. This is similar to our last example. The only difference here is that instead of tangent of x being our argument u, we will have e to the x being our argument u. So this derivative will be 1 over the square root of 1 minus u squared, but u here is e to the x. So e to the x quantity squared times du dx. That's the derivative of e to the x with respect to x. So that's times e to the x itself, because as we know, e to the x is the one function whose derivative is itself. So we just get e to the x over the square root of 1 minus e to the 2x. The final example for this video, we'd like to find the derivative of arctangent of x over 1 plus x squared, the quantity squared. So we have a quotient here, so we should use the quotient rule. If you'll remember, if you recall, the derivative of a quotient, u of x over v of x, is just going to be v times du dx minus u times dv dx over v of x, the quantity squared. And v and u here are functions of x. I've just, for ease of writing, left out the of x part. So I'm just going to keep that circled so you can bear that in mind as we work this example. So we have the denominator v, 1 plus x squared, the quantity squared, times the derivative of arctan. Well, the derivative of arctan is just 1 over 1 plus x squared. So minus the numerator, which is arctan of x, times the derivative of the denominator with respect to x. And here, notice we'll have to use the chain rule because we have a function squared. So the derivative of that denominator with respect to x is going to be 2 times that function, which is getting squared, times the derivative of that function, which is here the derivative of 1 plus x squared is just 2x. And we have all of this divided by the denominator squared. Well, the denominator is itself a quantity squared, so we will have the 1 plus x squared raised to the 4th power. Oops, and this line should extend all the way out here. So if we do some algebra, this first term will become 1 plus x squared. And this chunk right here will become 4x times arctangent of x times 1 plus x squared. And in the denominator, you'll have 1 plus x squared to the 4th power. So we can factor out a 1 plus x squared from the numerator. And we get what? 1 minus 4x times arctan of x over 1 plus x squared to the 4th power. Here we get 1 minus 4x arctan of x over 1 plus x squared to the 3rd power. So if you've followed along so far, I think you're ready to look at the more conceptual aspects of the derivative, what it really means, and some of its applications, which are the topics that we'll be covering in future videos. There's certainly more difficult differentiation problems you might be asked, but it gets pretty boring trying to work derivative problem after derivative problem, so we'll move on to more interesting topics.